Right, there's a lot of information here. This is the introduction to waves. First of all, you need to know a wave is a transfer of energy without a transfer of material. Okay, so me throwing a ball at someone is not a wave because I'm transferring material across there. But sound wave is a wave. Light waves are a wave because they transfer energy from one place to another without material moving from one place to another. Examples of waves are sound waves, waves on springs, waves on water, earthquake waves known as seismic waves. Now all of these waves are mechanical waves and they need a medium to go through. They need a substance to go through. So sound needs a solid liquid or gas to go through. If there's none of those particles, sound cannot travel through it. Same for obviously waves in a spring need a metal spring, water waves need water, and earthquake waves need rocks to go through. They're mechanical waves and they need a medium to go through. Some types of waves, such as light, microwaves, radio waves, and ultraviolet, don't need a medium to go through. These, in fact, are electromagnetic waves. They don't need a medium. They all belong to the same family. You need to know that waves can travel in two ways. The first way is transverse. Now, I've deliberately made the S's really, really big to make you remember that the transverse is the S-shaped wave. And if you notice at the top there, I'm showing the energy is going from left to right. So there's an arrow there showing the direction in which the energy is going. I've got a rope here. The red line represents a rope being shaken up and down. And if you notice the black dots on there with arrows on it, is actually showing you where the individual part of the wave or rope is actually moving. The individual part of the rope actually moves up and down across the direction which the energy is moving. In fact, we say the vibrations, are perpendicular to the direction which the wave is moving. Okay, and that is transverse. The word trans means across, so that's transverse waves. Longitudinal waves, basically the energy is going in that direction, and this time, if you notice, the individual particles in the spring are vibrating backwards and forwards, parallel to the direction of the energy. So this is why it's called longitudinal, because the vibration is along the spring. And when you get the spring and you shake it backwards and forwards like that, you end up places where the spring is squeezed up. They're known as compressions. And the bits where the springs are spread out or stretched out are known as rarefactions. R-A-R-E-F-A-C-T-I-O-N. Rarefactions. So those are the two waves in which waves travel. The two ways in which waves travel: transverse and longitudinal. Well, you need to know what we mean by frequency. Frequency is the number of wave crests passing a point each second. It is measured in hertz, Hz. So for example, if I said 20 hertz, that means 20 wavelengths per second. You sometimes see the word hertz with a prefix in front of it. So for example, you might see the KHZ. KHZ means kilohertz, that means 1,000 hertz. If you see capital MHZ, that's megahertz, that's 1,000,000 hertz. And if you see capital G in front of it, it's gigahertz, and that means 1,000,000,000 hertz. This is showing you what a couple of other terms you need to know about. So the dashed line shows the rest point of, say, the string, and the amplitude is half the total height. Okay. The other features to know on a wave is you've got troughs, the bottom of the waves, peaks, the top of the wave, and if you measure the distance from, say, peak to peak, that is known as a wavelength. You could also measure from trough to trough, and that would be a wavelength. Here, for example, I've actually got two wavelengths. Make sure you understand what I mean by two wavelengths. Two complete cycles is in this diagram here. Right, you'll also need to know about the wave equation, and the wave equation is wave speed equals frequency times wavelength. It allows us to work out the speed of a wave and the frequency and wavelength. The wave speed is measured in meters per second if the frequency is in hertz and the wavelength is in meters. The symbols we sometimes use for this is wave speed's got a symbol V, frequency's got the symbol F, and wavelength's got the symbol lambda. So you've never seen that before. Lambda is a Greek alphabet symbol. It looks like a sort of giraffe, and that's known as a lambda. And of course, it can appear in a triangle just like that there. And I think that is everything you need to know about waves.